This video will take you for a short visit on 4 liver specimens. The first one here was injected with carbon, and you know from lecture that the von Kupffer cells pick up carbon and they're located in the sinusoid. So every place you see the black substance, that is carbon that has been engulfed or phagocytosed by the process of phagocytosis within the Kupffer cells. So that's what this specimen, and you can see the morphology of the liver, the portal areas, and the central veins, such as this one right here. So now let's go to the next specimen of liver, the one that's stained with silver stain. So you can see the framework of the liver as, so every place you see the network of dark lines, those are reticular fibers, and they're located in the space of Desai. So you just have to zoom in, and that's what this specimen is valuable for. And you can see the round black objects; those are nuclei. You can also see here is a bile duct, and you can see the columnar epithelium lining it, but it's also surrounded with a heavy concentration of reticular fibers. And then this would be a portal vein here. And then if we look at a central vein, let's see where we see a nice central vein. Well, maybe over here is a fairly large central vein right here. And you see a concentration of reticular fibers underneath the endothelium of the central vein. And so now we're going to go to the next specimen, and you can look around this specimen and find many examples of how complete the network of reticular fibers forms the stromal framework to hold the delicate hepatocytes, or the liver cells, as well as the vessels, etc., etc. The next liver specimen is stained with hematoxin iosin. It's pretty well fixed, and there is an annotation, but what this is outlining a portal area. It's a rather elongated portal area, and there's a central vein here, and this specimen was stained not only with hematoxylin but also with the PAS reaction, which reacts for glycogen. And you can see here, as the annotation notes, that there's more heavy concentration of glycogen around the central vein, toward the central vein, than there is toward the portal area, because with the Zener arrangement of liver structure, that as compared to the classic central vein and then the portal areas surrounding the central vein, the Zener arrangement is reflecting the blood flow, the oxygenated blood that comes in from the hepatic artery and then flows across the sinusoids to the central vein, and by the time it gets about 1/2 to 2/3 of the way across, then the blood has, a lot of the oxygen has been extracted, and so these cells, the glycogen ones, are undergoing anaerobic metabolism, and that's why you have the glycogen. And that's where you find the first storage of glycogen in the liver. So study this specimen with reference to not only the morphology, which is pretty good, and seeing the portal areas as well as the central veins. You probably won't be able to recognize for sure Kupffer cells, like this may be a Kupffer cell here, this nucleus that's present in here, and if I enlarge that just a bit, it'll be out of focus, but that's most likely a Kupffer cell nucleus. But of course, when the Kupffer cells have engulfed something like in the carbon injected specimen, that they're pretty easy to see. So let's go to the next specimen now. So then just a short visit to the liver specimen in which the gallbladder is shown, And normally the gallbladder is a sac-shaped structure, so part of the wall of the gallbladder is missing in the preparation of the specimen. But and you can zoom in on the liver, and it's stained with hematoxin eosin, although the cells are fairly poorly fixed, so they're rather empty. So the best part of this specimen is to study the gallbladder. Remember, the gallbladder has epithelium, tall, simple columnar epithelial cells that absorb water, because the gallbladder stores bile, which is really bile salts. It's a detergent to pour into the duodenum to emulsify the lipid and the fat that you take in your diet. But there are no goblet cells here at all. That's one diagnostic feature. It looks like a villus, but if you look, there are absolutely no goblet cells anywhere, and there are no intestinal glands. So those are clues. And then, of course, you have the smooth muscle, which is forming the outside and enables the gallbladder to contract and squeeze and squirt bile into the duodenum. Okay, so that includes just a brief tour of several specimens of the liver.